In this section, we're going to take a look at factoring. Now, I am sure at some point in your life you have factored before. In particular, I'm sure you've factored numbers. For example, we might say 24. 24 can factor as 6 times 4. It can also factor as 12 times 2. It can also factor as 8 times 3. So there's lots of ways to factor 24, but the important one for us would be to write it as 2 cubed times 3. We would call that the prime factorization, because 24 can factor as 2 cubed times 3. 2 is a prime number, 3 is a prime number. Alright, now in this class, we're not going to be factoring numbers, we're going to be factoring polynomials. And when you factor polynomials, there are several steps you go through. The first thing you always do is you look for the greatest common factor. And I'm going to do some examples of all of these here in just a few minutes. Greatest common factor. Once you've found the greatest common factor, you count the number of terms. If there are 4 terms, you use a technique called grouping. Whoops. Grouping. If there are 3 terms, you actually have 2 choices. You can use guess and check, or you can use grouping. And finally, if there are only 2 terms, I'm going to erase here. If there are only 2 terms, you use some formula. And we'll see these here in a few minutes. Alright, so those are the steps we're going to go through. So let's do some examples now. Alright, so greatest common factor. Greatest common factor problems might look like this. I might give you 5y minus 20. So what you do is you look for the things that each piece have in common. And what I see for this one is I have a 5 and I have a 20. 5 and 20 have the number 5 in common. So I would factor out the 5 and then I would put my parenthesis and I need to figure out what's left over. So 5 times y will give me the 5y and the minus 4. 5 times minus 4 will give me the minus 20. Alright, so that's a pretty basic one, pretty simple one. Let's do one that's a little more complicated. 12x cubed plus 16x squared minus 8x. Alright, what I have to do this time is I have to look at the numbers. So I see a 12, a 16, and an 8. 12 and 16 and 8 all have a 4 in common. And then I also need to look at the letters. I've got an x cubed, an x squared, and an x. They all have x in common. So there's my greatest common factor. So I factor that out. And then I'm going to have left over. 4 times 3 will give me the 12. And then to get the x cubed, I need an x times an x squared. Plus 4 times 4 will give me 16. X times x will give me the x squared. And then minus 2. 4 times 2 will give me the 8. I already have the x, so I'm good there. Okay, so there's greatest common factor. If you have 3 terms, let's do 4 terms first. 4 terms. If you have 4 terms, you use a technique called grouping. And we'll see why it's called grouping here in just a minute. Okay, so here's a polynomial with 4 terms. Let's say I had x cubed plus 3x squared plus 6x plus 18. The first thing I would do is I would look for a common factor, but I would notice there isn't one. I've got x's in the first 3 terms, but there's no x together with the 18, so there's no x in common. And I've got 3, 6, 18. They all have 3 in common, but the first term just has x cubed. There's no 3 there. All right, the reason this is called grouping is what we do is we group them in pairs. So I put the first 2 in one pair, and I put the second group in another pair. And then what I do is with each pair, I look for the greatest common factor. So for x cubed plus 3x squared, my greatest common term is an x squared. Left over, I would have x plus 3. Plus, my second group, the greatest common factor is a 6. Left over is x plus 3. Now, here's the key to this. You know you've done this right if these two pieces of the parenthesis match up perfectly. If they don't match up perfectly, there's two options. Either you've made a mistake, which is the most likely thing, or this won't factor by grouping, which does happen sometimes, and we'll actually see that later in this course. But for now, if you're factoring, those two things always need to match up. Okay, so we write down the x plus 3. That's one parenthesis. And then our second parenthesis is going to be what's left over. So what I tend to think about is if I get rid of the x plus 3's, like so, what do I have left over? Left over is x squared plus 6. Okay, so there's that one factored. Let's do one more of those. How about if I gave you x cubed minus x squared minus 6x plus 6. Okay, again, I notice I have four terms. Again, the first thing I would do is I would look for greatest common factor, but there isn't any. So I factor by grouping. So I'm going to write down x cubed minus x squared, and then I always put a plus here, minus 6x plus 6. And I look for my common factor. In the first group, my common factor is x squared. I think that's what we had last time too. That's just a coincidence. X minus 1. Plus, now this one, I notice that I have a minus in front here. In general, we don't like to have a minus in front. So what we're going to do this time is we're going to factor out a negative. So we notice that we have a 6 as our common factor, but I'm going to factor out a negative. So I'm going to have negative 6. But if I have a positive and then I have a negative 6, I don't like the way that looks. Generally, we don't do that. So I'm going to erase a little bit here. Generally, what we would do is we would factor out negative 6. And then if we factor out negative 6 times x will give us the negative 6x. And the negative 6 times negative 1 will give us the positive 6. And what happens a lot with these problems when this sign here in the middle, back at the beginning, starts as a negative, people a lot of times will have this sign here wrong. What should tell you that it's right is that this set with the parenthesis and that set with the parenthesis are exactly correct. So if you end up with an x minus 1 over here on the left, but an x plus 1 over here on the right, go back and check your signs. You've probably made a mistake. All right, so here's our answer. The x minus 1 is now common in both pieces. And if the x minus 1 goes away, left over is x squared minus 6. Okay, so there's that one factored. Factoring with three terms. My guess is you've probably factored with three terms before, but you may not have done it the way that I like to do it, the way that it's done in this book. Alright, so let's start with an easy one. An easy one is t squared minus 2t minus 15. This is an easy one because the leading coefficient is the number 1. What I mean by the leading coefficient is we don't usually write it in, but there's really a 1 right there. If the leading coefficient is the number 1, then factoring is generally pretty easy. You write down two sets of parentheses, and you're going to be doing FOIL, which most students love FOIL. You're going to be doing that backward in a sense. So how can you get t squared out front? To get t squared out front, you use a t and a t. How can you get 15 on the end? To get 15 on the end, you could use 1 and 15, or you could use 5 and 3. I think the right one in this case is 5 and 3. And the reason I think 5 and 3 is correct is because I'm looking at the middle number. I need to get a negative 2. If I use a negative 5 and a positive 3, that gives me a negative 2. and a negative 5 times a positive 3 will give me a 15. And then what you can do with these is you can just check. And the way you would check is to just go ahead and do FOIL. If I do FOIL, I have t squared plus 3t minus 5t minus 15. And if I combine my like terms in the middle, I do see that that's the right answer. Okay, so that's pretty easy if the leading coefficient is 1. Not so easy if the leading coefficient is not 1. And let me give you a good example of that here. How about 6x squared minus 7x minus 20? Now, the difficulty in this is when you put your parentheses down, you've got a couple choices. For 6x squared, you could use 3x and 2x. Or you could use 6x and 1x. Which one's the right one? The truth is, there's really no way to know. So you have to take a guess. I'm going to guess 6x and 1x. Then on the end, you need to get 20. To get 20, you can use 1 and 20. You can use 2 and 10, or you can use 4 and 5. Which one's the right one? Again, there's really no way to know. I'm going to take a guess. I'm going to put a 5 here and a 4 there. And then let's see, I need it to be a minus 20, so I know one of these has to be positive, one of them has to be negative. Again, I don't know which one. I'm going to take a guess. I'll put a positive there and a negative there. Is that the right answer? Well, I don't know. To check, to see if that's the right answer, I go ahead and I do FOIL. I have 6x squared minus 24x plus 5x minus 20. And unfortunately, when I combine these two terms in the middle, I get a minus 19x, but I was supposed to have a minus 7x, so it didn't work. So what's wrong? I don't know. It could be the 6x and the 1x. It could be the 5 and the 4. It could be the position of my plus sign and my minus sign. Okay? So you can see the issues here when the first number is not the number 1. When the first number is not the number 1, there's lots of guessing involved. Alright, so let's try this method again, this problem again, but I'm going to do it by a different method, one that you might not have seen before. This is the one that I prefer, and it's the one that's actually shown in your book. And the method is the grouping method, just like we did a minute ago for 4 pieces. Alright, the way this grouping method works is you multiply the numbers on the end. So I'm going to take 6 times negative 20. 6 times negative 20 is negative 120. Now, what I need to do is I need to factor this number. I need to factor the number negative 120 so that when I factor it, the two numbers add up to be the number in the middle, which is a negative 7. So let's see, how can I factor negative 120? Well, let's see, there's lots of ways to factor 120. 10 and 12 would work, 2 and 60, but I think the one we want, negative 15 and 8. Because negative 15 and 8 add up to be negative 7, and negative 15 times 8 is negative 120. Alright, so here's what we do. We go back to our original problem. We're going to have the 6x squared. But then we're not going to write negative 7x. We're going to replace it with our factorization. So we're going to have negative 15x plus 8x. And then the minus 20. So you see what we did. We rewrote the negative 7x using 2 pieces. And the reason we do that, we write it using 2 pieces, is now we have 1, 2, 3, 4 pieces. When we have 4 pieces, we can use our factor by grouping. So I group them. I got 6x squared minus 15x plus 8x minus 20. Take out my common factors. Let's see, 6 and 15 have a 3, and then there's an x. 2x minus 5 left over. And 8x and 20 have a 4 in common. 2x minus 5. Once again, I'm quite confident I did it correct because I see that those two match perfectly. So I write it down. 2x minus 5. And then left over, 2x minus 5s are gone. is 3x plus 4. Alright, so there's an example of how you can factor by grouping when you have three pieces. It works quite well. There are other techniques that you can use. This is, again, the one I prefer, and this is the one that's in your book. Alright, the last thing we need to talk about is what do you do if you have two terms? If you have two terms, there are some formulas. Okay? I'll just write them down, I guess. One formula is called difference of squares. It looks like a squared minus b squared. That factors as a minus b and a plus b. Or you could switch the order. You could write a plus b, a minus b. It doesn't matter. Second one, a squared plus b squared. That's sum of squares. Does not factor. So something you have to watch out for is things don't always factor. That could be what is known as prime. Then there's two others, the cube formulas. There's difference of cubes, a cubed minus b cubed. This factors as a minus b times a squared plus ab plus b squared. And then there's the sum of cubes, a cubed plus b cubed. This one is a plus b times a squared minus ab plus b squared. So you'll notice these last two formulas are very, very similar, just a difference in where the minus signs go. Alright, so let me give you just a couple quick examples here. 9x squared minus 16. First off, I look for my greatest common factor. There isn't one. If there was one, I would take it out first. But then I notice that I have two terms, and I notice that I have x squared, so that's a square. I notice I have 9. 9 is a squared. It's 3 squared. And I have 16. That's 4 squared. So this one's just going to factor as 3x minus 4, 3x plus 4. So that one's pretty easy. Students don't usually have a great trouble with the difference of squares. This one might cause a little bit of confusion though. X to the fourth minus 81. What you need to recognize is x to the fourth is really x squared squared. So you really do have a square there. And 81 is 9 squared. So that's going to factor as x squared minus 9 and x squared plus 9. But then something to watch out for, notice that x squared minus 9 is difference of squares again. That one will factor more. So we have x minus 3, x plus 3. This one, that's our sum of squares. Sum of squares won't factor. Try as hard as you might, you won't be able to get it to factor. Alright, let me finish with one example of the cubes formulas. These are going to look something like 8x cubed plus 27. And what you need to notice is that 8 happens to be 2 cubed, so this one is 2x, whole thing cubed, and 27 happens to be 3 cubed. Alright, so I'm going to write down the formula here to help you remember. A cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. And in this case, we're using a is that, so a is 2x, and b is the number 3. Alright, so here's my answer. 8x cubed plus 27 factors as a plus b. A plus b is 2x plus 3 times a squared. For a squared, I need to take 2x, and I need to square it. 2x times 2x is 4x squared. A very common mistake I'll see there is people will write 2x squared. They'll forget that they got to square the 2. Minus a times b, 2x times 3, that's 6x, plus b squared, 3 squared is 9. Now, what's tempting on these is you do have a trinomial left over, something with 3 pieces, and just a few minutes ago we learned how to factor trinomials, but I will tell you for these problems, that trinomial that you end up with right there will never factor. So this is actually your final answer. You can try to factor that if you want, but I promise you it won't work.